Okay, so today we're continuing with our look at how Java interacts with the outside world. We're going to look at two other ways. So far, we've seen reading in text files, and again, for our purposes in this class, text files is about as far as we're going to go, with actually with one exception today. In general, you know, binary files typically have their own special issues with that. There are third-party libraries to deal with pretty much every type of format that's out there. So uh, you can read PDF files if that's what you're into. There are libraries for reading all of Microsoft Office's documents. So I can read and even create a Microsoft Word document from within a Java program. Likewise with Excel spreadsheets, which are different than the CSV files that we've been dealing with here. There are ways of interacting with databases, and pretty much anything that you can do with another file or format can be done. The issue is that it requires third-party libraries, and again, for the purposes of this course, we're sticking closely to what Java can do. So today, we're now going to read a text file from a URL. So it's as we'll see, it's actually fairly straightforward, uh, with the one exception of the URL. There's a class called URL, which interacts with things on the internet. And an issue comes up when you start doing that, which is that when you're pulling data over a network, you don't want to be reaching out one thing at a time. And that's where this idea of a buffered stream comes in. And we'll talk about that. And then this is first and possibly our only uh, binary file that we're going to interact with. But if you have a zip file, you've all dealt with many zip files in the course of working on computers. And so typically what you would do is, well, in the old days, what you had to get an external program. Like if you're on Windows, it would be WinZip. On these days, if you're on Windows and you just double click a zip file, what it does is it kind of opens up in something that looks like a file explorer, and then you can extract them. On Macs, you could just simply double click a zip file and it just extracts it. So it's pick your poison. There are both commercial and free applications to deal with that. One of my favorites is something called 7-Zip, 7Z, because that also deals with other zip form. There are a variety of different zip formats. So if you haven't peeked under the hood of what this zipping is about, it has to do with the fact that in a typical file, particularly a typical text file, there's a lot of space. In other words, the size of the file has a lot of redundancy in it. And so what these clever people did a while back, and they're probably still at it, is they came up with ways of storing the same data, but eliminating the redundancies. And exactly how it's done is a little bit beyond the scope of this course, but just know that these things exist, and typically when you zip a file, it gets much smaller, and that particularly for uh, sending files over the internet, like whether you're downloading a file or even emailing one, then you want it to be as small as possible. You don't want to be sending these big huge things. So that's where the zip business comes in. In fact, many of the data sets that you encounter are in fact zip. And in fact, the movie data set that I had you read in the previous assignment, in fact, was zipped according to a slightly different format called gzip. And so since we hadn't talked about that, actually Java can handle gzipped, but zip is, so gzip is one thing, zip is another. Zip is a little more common these days, particularly amongst Windows folks. So that's what we're going to be dealing with here. Okay, so, and again, in keeping with recent approaches, rather than giving you death by PowerPoint, I'm going to give you death by code, which is hopefully a little bit more informative. All I got to do is find my NetBeans. Okay.
So did you upload your code from yesterday?
I believe I did. Let me double check. Well, it's, oops, looks like I didn't. My apologies. Okay, I'm doing it now. Okay, yeah. Okay, so the first thing we're going to do is just give me a second here. Is we're going to go to a remote site. The remote site is something called Project Gutenberg. And what it does is it has a lot of ebooks. And that can basically be downloaded in a variety of different formats. They have HTML, they have...
Marty, we can't see what you're doing right now. I think, are you on a website?
Yeah, I'm just getting the URL. Okay. All right, so let's see what that's about. Okay, so first, yesterday I talked about the command line, and the idea is that to connect to an external resource, you typically need a name of it. On the file system, we had relative and absolute paths. Typically, relative paths are better. For example, in the last assignment, what many of you had done was hard code an absolute path to the movies file on your computer. And so if I try to run it on mine, it obviously is going to fail because I can't read from your computer. So I kind of commented about that. So yesterday we talked about how you can send stuff in the command line. So here's another pattern that I found to be useful. You notice that when I required reading in from the command line, I would occasionally just sort of do the right click and run the file like that. And what I want is I want it to be both ways. I want a dessert topping and a floor wax. And so here's a pattern that I like for this. In other words, I'm going to have a default that's going to be hard coded in, but if I want to override that, then I'll put it on the command line. So here's we're dealing with the URL, so I want the URL name. That's bad. So what I'm going to do is I'm going to check to see whether there is something on the command line. And if there is, then I'll read it in. And if not, then I want to use this URL just as a hard-coded. Oops, this should be a question mark. Yeah. Okay. Now, I think I might have briefly mentioned this syntax previously. Is this something which is unfamiliar to you? This question mark and then colon?
Mostly, yes.
Okay, so you've seen that before, yeah. Yeah, basically what it is, the syntax is you have a Boolean expression and then a question mark, and then if it's true, then you do what's in here, and then the colon is if it's false, you do the other thing. So what's good about this is that if I put something on the command line, then I will use that, and if I don't, then I can just use this, which is the default. Okay, so this is a URL, and notice it's pointing to a text file. And this is actually the plain text, or it's UTF-8 actually, but that's as plain as you get these days. It's a plain text electronic version of a particular book. And Project Gutenberg is one that has a whole bunch of these, and they're freely available for download, and so it's a nice way to at least sort of test out what we're doing here, which is getting a resource from the internet and doing something with it. So now, instead of a file, there's a class called URL, and yeah. And you basically instantiate it while passing a URL to it, and getting to fix the imports. It's in part of a JavaNet package. And then again, whenever you see red squigglies, you just stop and fix them. And in this, it's unreported exception, malformed URL here. We're surrounding it. Again, as I said, we will go a little bit more deeply into what these exceptions are about. You've already started encountering them. One thing that Java is very good about is naming their exceptions in a kind of a self-documenting way. So is it clear why in constructing a URL object, which is going to correspond to a resource on the internet, is it clear why this malformed URL exception is something that should be worried about? Hopefully it's clear, because there are only certain things that are permissible for a URL. So HTTPS is one, HTTP is another. There are others such as FTP, and even you can refer to a local one by file. Again, these are all standard internet protocols. And if you kind of mess that up in the string, then it'll kind of throw it here. So just to kind of show that. All right, so let's make a terrible URL, and now when I just try to run it, it will give me, well, no protocol. So let's make that a protocol. Okay. It's the unknown protocol. Okay, so it has no idea what this thing is. Whereas if I do this, again, no error, so at least it made it past it. Okay, so what that means is that this URL object is now connecting to this resource here. And if I want something else, I can put it on the command line and run it with the green arrow. Of course, I would have to set up I'd have to create a new configuration for that. So, all right, so what we can do here is Okay, now I'm going to introduce a buffered input stream. And the book talks about this. And now the thing about a buffered input stream is that it requires another input stream as its argument to its constructor. Okay, so where can we get an input stream? Well, we can get it from this URL, because the URL has a method called openStream. And if we look at well, you can't see it, unfortunately, but the Java doc says that this will, assuming that we've been able to get a legitimate resource. So at this point, we don't know if there's actually anything there, but we have if you make it to this line, if you make it past the constructor for URL, you know that the protocol at least is correct. So we have a correct protocol, and the form of the URL is a correct one. Okay, I wanted to call this a buffered stream. Okay, so we're taking the stream from this URL and we're putting it into a buffered stream. Now, the reason for a buffered stream is that when especially if we're reading things over a network, we don't want to kind of go out and get it onesies at a time. What the buffered stream is going to do is it's actually going to pull things down, pull a chunk of things down, put it into a buffer, and then dole it out. And then when it kind of runs out of that, it'll pull some more down. So what that does is it basically eliminates a lot of the network traffic. In other words, if we don't do that, then it will, we're just kind of reaching over the network for every little thing. And that's not a great idea. So you want to use a buffer. Now, it also has an unreported exception here. And that's an IO exception. So now what we can do, notice the options here. So we can add the throws clause. What that does is that adds it to the main. You usually don't want to do that. Sometimes you do. Again, we'll talk about that when we get into exceptions. But in this case, we're just we're saying, okay, there could be an IO exception going on, and that could have nothing to do with the program. That is, in the middle of running this, your network goes down. That's been happening to me a lot lately for some reason. And so if that happens, then you'll get this sort of IO exception. So with this, what Java did, and it kind of borrowed this from the way that Unix was operating. And for those of you running Mac, under the hood, Mac actually is Unix. So just FYI. The idea there is that you have these little atomic applications that would just do like one thing, and you kind of pipe them into the other. So the way this works here is this URL is going to be grabbing data from this resource, assuming it can find it. The buffered stream is going to sort of take that, it'll grab a chunk of that so as to minimize network traffic. Okay, so that now we have a buffered stream, we can now apply our scanner guy. And again, the pattern is to kind of put it out here, mostly because we want to finally, when we do our finally here, we want to make sure that we close it. And this is particularly important when we're doing network stuff. Okay, so now notice that scanner, which is heavily overloaded. One of its constructors is just some kind of input stream, and a buffered stream is an input stream. And so what this says, so notice the connection here. So the URL is going to be grabbing bytes from this URL, assuming that there are bytes to be grabbed. the buffered stream is going to grab them a chunk at a time into a buffer. And then the scanner is going to take that buffer and apply what it does to read it. And again, the first thing that you want to do with any of this is make sure that you close it up. So, and now, in fact, every one of these, this stream that you've opened up from the URL, this buffered stream, and the things that the scanner is doing under the hood, they all need to be closed. However, when you notice that I'm only closing the scanner, and that's because when you close the scanner, it also closes the input streams that are behind it. And the way that these input streams work when they're closed, like all of the Java streams work this way. So if I've chained a stream, so when I close the scanner, it says, oh, I'm getting my data from this buffered stream here. So I'll close that. And then when the buffered stream closes, it says, oh, I'm getting my data from this other stream here. And so I'll close that. So when you close the scanner, it kind of cascades out. If you want to be OCD about it, you can explicitly close each one of the other ones, but it isn't really necessary. Okay, so let's just see what we got here. So oops. Let's just sort of read it line at a time. Okay, so notice that this is exactly the same as what we were dealing with. Let's just sort of print it out. And let's just see what we got. Just to kind of mark our progress. Let's just sort of print out what we've found here. Okay, so just to make sure that we're kind of connecting to the right thing. So we're going to find the URL if we assuming we find it. So let's okay, so it found it. And then notice what it's doing is it's reading all of this text from this URL. And it took about 4 seconds. So that's not a whole lot of time. And this was the Project Gutenberg ebook of Frankenstein by Mary Shelley. Okay, so now what kinds of things can we do with this instead? Well, let's count the words for this. Okay, so instead of just kind of printing it out, let's do something like let's create a one of these guys, and instead of this, let's just I'll comment that out. So let's okay, now the difference between scanner and next is and next line gives you the whole line. Next just gives you the next word, and we'll see what it means by a word. So okay, you see what we're doing? We're reading it now word at a time, not line at a time, but word at a time. And that's, again, particularly if we're using a buffered stream, then that's not so terrible. And what we'll do, let's just sort of print out what we found. In one line at a time. Okay, so so what we're doing is we're taking the words and we're basically putting them in here. So let's see what we get. Okay, and as you can see, what we're getting is a bunch of gobbledygook as well. So you'll notice that what Scanner considers to be a word is typically stuff between spaces, tabs, and new lines, but not things like punctuation and stuff like that. So how can we, again, particularly here, you know, we're getting some gobbledygook there. So how can we fix that? Well, it turns out that with Scanner, we can specify a regular expression, either, and we won't get into it, but Java actually has a very sophisticated way of using regular expressions, using things like pattern and matcher and stuff like that. We will not get into that unless there's a strong demand for it, but we can just give it a pattern. And so one of the patterns that we can give it is something that is not a word. Okay, remember that small w means something that is a word. Capital W is something that's not a word. So again, let's look at this just as a very simple regular expression. This says we need 2 backslashes to create 1 backslash in the string for the regular expression. Again, capital W means anything that's not a word. And the plus means we can have one or more of it. So particularly for here, notice that these things are not going to be a word. And there are 2 of them. So the plus says 1 or more. So this says that the delimiter that Scanner is going to be using is going to be 1 or more characters that's not a word, not part of a word. And let's see what that produces. Okay, so now you see that the punctuation is now gone. But now we find that there are numbers here. Okay, so the numbers are not what we want. So how can we deal with that? Well, remember that a backslash d in a regular expression, lowercase d, is any digit. And so we can use this bracket notation that says either a sequence that has either a number or not a word is going to be what we use for our delimiter. And now when we run it, we're now the numbers are gone. We're almost there. Again, notice that the alphabetical, it's not alphabetical order, it's lexicographic. So all of the capital words, all the words that start with capital letters are first, and then the ones that start with the lowercase are after that. Again, so how can we deal with that? If we want alphabetic, well, we need to use another comparator, but we're not gonna go there on that. Okay, so that's that. So again, what have we done? We have identified just by a string, by something that you would type into your browser, identified a text file, and that was located remotely. We've connected that to a URL object. We've connected the stream of data coming from that URL to this buffered stream, and the reason for that's strictly speaking not necessary, but something that we typically that you want to do when you're reading large amounts of data. This also is true the other way. When we're writing large amounts of data, there's a buffered output stream that you want to use as well. So just the key here is just the concept of using a buffer when you're reading or writing large amounts of data. And then what we did was we split it by applying just a little bit of what we used on a regular expression. Again, this to really fully do this, we need to get a little more complicated. And unfortunately, these regular expressions are it's a very powerful language. It's a very powerful way of processing text. And it's used by things like when you type into a form on the internet, and it needs to be an email address. Well, email addresses have like a certain format. And so they will typically use something like a regular expression to make sure that that's a legitimate email that you've typed in, not just some random text. Okay, so anyway, so we've learned a new method in Scanner, which is to tell it to use, instead of its default delimiter, which is how it decides what it is and isn't a word, to use another delimiter that we wanted. And what we wanted was something which wasn't a part of a word and wasn't part of a number. And then we just put this into this sorted set, and we're able to get the contents of what we had. Just to kind of finish this with, if we want to read from the command line, it doesn't have to be the same name, but let's, okay, if I give it, I'm not sure what this is going to do. If I typed in, this is the homepage of NPS, NPS's outward-facing website.
Sure, we're still only seeing your code.
Oh, you can't see. Drat. I wish they would. Okay, so what I did was I created another configuration. I need to point it to this main, and then I'm going to give it an argument so instead of getting this Project Gutenberg thing, I'm going to get this. I'm going to try. This may or may not succeed. What it should do is it should get the index.html file there. And so let's see what that does. Okay, so it actually found this is sort of parsing out what is on the home page for nps.edu. And since I was parsing, it's actually an HTML file, but since I was just parsing out the words, this actually kind of extracted all the stuff in between. If I was actually interested in just kind of what that was doing, let's run it this way. Oops, not that way. Let's run it from here. Okay, you notice here that it is now giving me the actual HTML file, because HTML is plain text, and so this is giving me what I had there. So let's just run it again, just to make sure. Okay. Okay, so now, all right, so now what I've done here, and hopefully this will come through when I committed. So here's that movies file, but it's zip format. So what can we do with that? Well, one of the things is you can unzip it on the file system and then just kind of use what we had before. But instead, I want to unzip and read the file. And fortunately, Java provides classes in order to do that. So I'm going to use the same pattern as before. I'm going to say, okay, I'm going to give the option of reading something from the command line. And if not, I'm going to use the default of this movies tsv.zip. Okay, so what it is a zip file containing that tab separated file that you used in the movies. Zipping that file, because it was text and had a lot of redundancies, zipping it took it, basically reduced its size by a quarter. In other words, the size of the zip file is 1/4 that of the original file. So, but now how can I read this now? Especially if we're dealing with something over the internet. Again, if there's a zip file on the internet I want to read, I could use something similar to what I just did, but just for illustrative purposes, I want to use just sort of a local one. So, and I always prefer to use to work with file objects, because the file objects have much more information than just the plain ones. Okay, again, a couple things to note. First of all, this is a relative path. Is it going to be relative to what? It's going to be relative to the quote user directory. That is the directory that I'm running it. The directory I'm running it from is the root of the project. That's what NetBeans does. Again, if you move to the File tab, you'll see that there are other things there that don't show up in the projects. So in the files, I've actually created this input directory. There's actually that same Frankenstein text. And there's the movies TSV zip. So if I were to unzip that, it would give me the movies file. And so what I'm going to do here is I am going to I'm going to read it in and unzip it on the fly. Okay, now in order to do that, I'm going to also be dealing with these input streams. So there's another input stream called a file input stream. Okay, and what does a file input stream do? It does what it says. If I give it a file, it will create an input stream that will read the bytes that are contained in this file. Now, I can also use a string, and I strongly recommend against that, because if I've given it the name of something which doesn't exist, then I'm going to find out when I try to connect the string to it. Instead, what I want to do is catch it beforehand. And the principle is that as soon as possible, as early as possible, you want to identify something that's gone wrong. And oops, %s not found. Okay, so if it's not found, and again, you want to sort of test this out as soon as possible. So build was successful. That means that it did not do this. If I fat finger something in there, it will say, okay, not found. This can be a little confusing because it looks like it's right there. What happened? I've accidentally put a space in, and it was not good about the space. Now, actually, there's a way around that. Let's put a bunch of junk in before and after. Okay, so if I do that, again, I got the right thing, but I've got a bunch of junk in there. I can actually, there's a method on string called trim. And what trim does is it removes junk, it removes space before and after the string. So that's just something to be aware of. Again, if I'm entering stuff like this, then I have more control over it. But sometimes, especially when you're reading things from a spreadsheet or a CSV file or a database, there may be embedded spaces in there that you'll encounter. So this trim thing is something to at least be aware of. Okay, back to our zipping here. Okay, so I set up a file input stream, which is going to read bytes from a file. Now here I'm also, you may have noticed that it took a while to kind of read this file. It's a fairly big file. So we can use our friend, the buffered stream. And now instead of connecting it to the URL stream as we did before, let's just hook it up to this file input stream. So that will make what we do a little more efficient, because again, the buffered stream is going to grab the bytes from the file in chunks. And then when we get it, we're just sort of talking to this buffered stream. Okay, so now, but now there's something called a zip input stream. And let's connect it to our buffered stream. Okay, so what have we done? We have the file, which are just a bunch of bytes that are sitting on the file system. This file input stream connects to those bytes. The buffered stream connects to the bytes coming from the file and then buffers them. The zip stream takes the bytes that it's getting and realizes that they're in zip format. So now here's the thing that we need to do is what the zip stream does is it's going to take all of the bytes in that zip file just as one big thing. But if you're aware of how a zip file is organized, inside the zip file there can be many different files as well. So it's both an archiver and a compressor. So that's so what we need to do in this case, I'm going to rely on the fact that there's only one entry. There's only one entry. In fact, I can kind of see what it is. It's the one entry is that movies thing. And so what I do is I move to the next entry. So if you can use this to unpack fairly sophisticated ones. We're just unpacking a single file. There's going to be one entry. So what this does is this moves basically the pointer in this stream to the beginning of this entry. And then notice that there's now an unreported exception. So in this particular case, we want to I can add a catch clause. And what that does is just adds another catch to what I've got here. And so now we have our friend, the scanner. And we can connect the scanner to this zip stream. And again, we want, before we forget, let's close it up. And again, that will, the scanner, when we close the scanner, it'll close the zip stream, and then the zip stream will then close the buffered stream, which will then close the file stream. And we want to do that. So just for now, since we only have a couple minutes, let's just sort of see what's there. Okay, so I mean, obviously, once we're here, we can do everything that we did in the movies thing before it was zipped. So hopefully this is going to work. And as you can see, what we're doing is we are reading the contents of that movies file, but not as a plain text file, but as a zip file. And this will take a few minutes even for a local thing. Okay. So again, what have we done? We've located a zip file on our file system. We've opened up a file input stream to read from it. We've opened up a buffered stream to buffer that, just to make it go a little bit faster. We've opened up a zip stream, you know, and this will work only if it's actually a zip file. And that has nothing to do with what the extension is. It has to do with what the format is of the bytes that it reads. Again, this is a binary file. A zip file is a binary file, but it's a special format that Java, in this case, knows how to, or the zip input stream knows how to deal with a stream of bytes that are coming in a zip format. And what we do is we position the stream at the next entry, and then we read it. In a zip file that has more entries, we would actually position for each entry. We'd have to figure out how many bytes were there, read that many bytes, and so it gets a little more involved. But once we have that, then everything we've done with our scanner is exactly as before. So instead of just doing this, I can now create my movies, put them in my movie holder, just as we've done before.